Now going to the next data set, so our next algorithm, that is KNN based model. So already the theory has been explained to you. So what we will do here also, the same concept what we use in case of KNN based regression will be used. So before that, let's say again, I'm just copy paste all the data sets. So here also what we are trying to do, we are using that standardized data only to avoid large calculation or large numbers. So let us copy paste the training data set from here. Put over here. And you have to just calculate the distance based on this value. So remember again the Euclidean distance, square root of difference between that particular value. So before that, I must keep the testing data set over here. So right now we are not using that label value or the success failure value in case of testing, as that will be useful when you will be comparing the two models. So first let us just calculate the distance. So here how we will calculate the distance. So you have to just first take some value over here, so which will actually act as a kind of a reference for you, or that particular point, which one actually for which data point he wants to predict. So let's say I'm just taking a random data point from this testing data, the first data only, and just put over here, and I'm trying to calculate the distance. So equal to SQ then take another bracket, this minus this, take square. So now this 37 should be fixed. So here plus again this again for the third feature. So here also you have to just fix, and finally for the last feature you just do it. And so this is the distance. Now remember, based on this ranking we can easily find out. First let us just rank them. So G2 so I have to just fix it, G2 to basically till G105, and then you have to just select which order you want to. So I'm more keen to the ascending order. Now if you click or drag all the things, so you will easily find out. So now the values. So here also, like regression, we have tried to just put the values, corresponding values or predicted value, the label value for that these top three or top five, and based on this, so we will use here not average. So we will use here the mode. And we'll just hit enter. So 0 appear multiple times, or the vote share for 0 is mode, so the prediction is 0. And similarly for 5, here also we will consider it as mode, not average, and consider it 0. So here what we found that based on this value, we have the prediction of 0, 0 for the first point, both for k is equal to 3. So this is the predicted success, rather I'm just putting this. So remember, 1 is success and 0 is failure. So we got both cases failure. So 0, 0. Now we have considered as general, so a number, so we should consider them 0. And this way we can predict for the remaining or rest of the numbers, and you can calculate the performance measure metrics, or the predicts accuracy, precision, recall, and your F1 score. So again, let's say we are trying to predict for this. So if we go there and just paste this value, so our prediction is 1, 1. So we can update over here 1, 1. So I have to just change the settings or cell format over here to general. For the third instance, zero, 0. Fourth one, is 1, 1. Now if we train for other data points, let's say maybe this one, and if you just automate entire thing, so you will find all the predicted values for these two types of KNN type of classification model, or where we are considering 3 nearest neighbor or 4 or 5 nearest neighbor. We can get all the prediction values. Now based on these prediction values, you can now evaluate your model. How? So we will use the same concept. That concept is nothing but that usage of usage of the same what we did in last time in logistic regression. The same confusion matrix we can just create out of it, and for that we have to calculate the false positive, false negative, true positive, and true negative. So for this case also, I'm just creating this 4 columns. Let's say these 4 columns, I'm just copying this copy, and here for the, so these 4 are nothing but for predicted for the predicted success k equal to 3, or 3 nearest neighbor. Now let's say I'm just changing these values. So basically I have to just define my column, nothing else. So my so if I just check, so these are, I'm just changing the name a little bit, so it will k equal to 3, again this is also k equal to 3, this is true positive for k equal to 3, and true negative for k equal to 3. Now these values I have to just put. So we will use the same logic that if or let's say we E2 minus H2. So here this E2 was our original value and H2 was our predicted value. So here what we will do, I can just change as per the sheets. So here in F column we have stored our original value, and on the G column we have our predicted value. So based on that, what we will do, so we can just modify this formula. So now this is, we are calculating false negative. So false negative is what? Where the positive cases are falsely predicted as negative, right? So means that 1 is predicted as 0 or success is predicted as failure. So in that case, the difference between F and I should be greater than 0. So I'm using the same logic. So here I'm just writing F, and in place, and second one I'm just writing G, and if we just hit enter, so we'll find the result. So now these are the result. So 22 instances we have found where the original ones are considered as 0 or predicted as 0. Now similarly for the false positive, where zeros are predicted as 1. So in that case same. So same, these two columns we have to just consider F2 and G2. So F2 and G2, those are less than 0 or minus 1. They are actually the false positive cases. So again, if you click enter, so it is only 2 instances we have created false positive. And last, again this 2 will be F and G. We are comparing, so F2 plus G2, that should be 2, means because both are equal or 1, those cases we are trying to find. So how many times? 8 times we rightly predicted positive cases or success. And again here also F2, G2. I'm just comparing, or equal to 0. If both cases are 0, definitely the sum is also 0. And so this is the number of rightly predicted 0. Now similarly we can create 4 columns for k equal to 5. So let me just create the columns for them. So 5, this is also equal to 5, this is equal to 5, this is also equal to 5. Now for this 5 I have to again just change the column's name. So again F and H. F is the original observation and H is the predicted success with the help of k is equal to 5 or near 5 nearest neighbor. So here F2 and H2, this 2 will be the column. Then again same, so F2 and H2 we will be considering. And again for the true posit, F2 and H2. So I have all the necessary values to compare these two models of k equal to 3 and k equal to 5. So now I am creating similar confusion matrix what we have generated when we dealt with the logistic regression testing. So here I'm just creating for 2. So I'm just giving a name to this confusion matrix for k equal to 3 and here confusion matrix for k equal to 5. Now here basically the true positive value should be assigned. So in our case the true positive value for k equal to 3, that is 8, so this value. Then our true negative is saved in the L column, so that is 13. And just take the first column, I column, where false negative cases are stored, basically falsely predicted negative cases. So so this is the cell where we have to put the falsely predicted negative cases who are actually 1. And finally I have the false positive case, which is equal to 2. So this is my confusion matrix right now. So what I can do, I can just calculate the accuracy. So in this accuracy is nothing but it indicates the rightly predicted instances or the proportion of rightly predicted cases. So that is nothing but this 8 plus 31 divided by all other cases, sum of all cases, that is 0.46. Now in case of k equal to 5, I have true positive cases, that is 7. So and true negative cases are 12, as it is mentioned in the P column. And I have falsely predicted ones or false negative cases are stored in M column, so that is 23. So again 23, and finally my falsely predicted 1 cases or false positive is stored in the n column, that is 3. Now based on these values, I can easily calculate the accuracy of my model. So here it gives, again I have to just find out the positive or right prediction divided by sorry, total prediction. That is 0.42. So in this case, if we compare my two models, then we can easily tell based on the accuracy that k equal to 3 actually produces better results. Now you can compare these two models based on other matrices that we have already used, maybe precision, recall, or F1 score. That's up to you, and you can decide which one is the best model. But accuracy and F1 score, these two scores are more, you can consider them as a matrix which can measure the performance pretty much well. So you can use two matrices. Right now here only we have compared the two models with the help of accuracy only. So in the summary of this topic 4, what we can say that we have learned how to implement regression type of problems, or how to solve regression type of problem and classification type of problems with the help of simple tool, that is Excel. And definitely these tools are very useful in solving small or simple machine learning type of problems, or in your day-to-day life of problems where you have to just predict some continuous value, or maybe predict or need to predict some class or category or level for a particular instance. So hope you have enjoyed this two demo, or this 4 demo of different algorithms for two type of problems, regression type and classification type problems in supervised machine learning. And definitely this is not the end. In the next topic we will definitely implement these algorithms in Python, which will be more interesting. We will try to understand or implement how these type of models can be implemented in Python with the help of your Jupyter Notebook, which is nothing but a platform to implement Python code. And further, you can use these codes for solving some small problems, or maybe in any domain, and that will be definitely beneficiary for you. And from right now, so for this video, I would like to thank again to the viewers for watching this video and for learning from this. Thank you.